Hello and welcome to this short introduction into arithmetic progressions. Basically this video will show you how to find a certain term of an arithmetic progression, the sums of arithmetic progressions, and how to find common differences and first terms from any given situation. Right, so basically here you can think of this as an arithmetic progression because we're adding on the preceding term differs from the next term by a constant, and this constant is called the common difference. You're adding on a constant each time, and that constant here is 3. You're adding on 3 more, because here we're adding 0 there, and then you're adding on 3. So you've added on 3 from the last one. Then you're adding on 6. You've added on 3 from the last one. And here you're adding on 9, and you've added on 3 from the last one. And you're adding on 3 more each time. And this is why it's an arithmetic progression. And to find a certain term, to find the nth term of an arithmetic progression, it's written like this: un is equal to a plus n minus 1 d. And now I'll jump straight into an example where we have, let's say we have u8 and u15, which equals 11, and that equals 21. Now to write this in the formula, we don't know the first term, or we don't know the difference, but they can be found. This equals a plus, right, 8 is equal to n, so n, 8 minus 1, 7, 7d. This one's a plus 15 is n, so 15 minus 1, 14d. Put that in brackets. And here you've got 1a, and you can't work this out while you've got 2 unknowns. So to get 1 unknown, you subtract the second one from the first one. So you'd have u15 minus u8 is equal to a plus 14d minus a plus 7d. This just gives you 7d. Because that minus that, you get 0 a's, and 14 minus 7, 7, which is equal to 21 minus 11, which is equal to 10. So then, d is equal to 10 over 7. And that's how you find d. And now that you've got d, you can plug it straight back into the formula. So we have u8, so we have u8 is 11, so 11 is equal to a plus 7 times 10 over 7, which is equal to a plus 10. So a plus 10 is equal to 11, a is equal to 1. Simple. And to even check that, in case you've made a mistake, you can even check it with the second bit of information you're given, just to make sure you're doing it right. So 21 is equal to a plus 14 times 10 over 7, and then you get 14 times 10 is 140. 140 divided by 7 is 20, so you get a plus 20. 21 is equal to a plus 20. A equals 1. So it works. So that is the first term of this series, 1. And the difference is 10 over 7. Now to find the nth term, I said the nth term of the sequence is this. This is the nth term. To find the nth term of of a series with n terms, the nth term of this arithmetic progression is equal to 1 plus n minus 1 times 10 over 7. But this is in its most basic form and requires a bit of expansions. 1 plus 10 over 7n minus 10 over 7. Now, you can take a seventh out of everything here, and you'll be left with a seventh of 7 plus 10 plus 10m minus 10, which gives you a seventh of 10n minus 3, and that's the nth term of this sequence. You just manipulate the nth term formula using the difference and the starting term you've got to get the nth term. And now, summation of geometric progressions. This uses a different formula. There are two formulas for this. Sn is either equal to start a new page. Sn is either equal to a half n multiplied by the addition of the first and last terms, but because you're not normally given the first and last terms, it's also equal to, this is the more common formula, a half n 2a plus n minus 1 d. And the second one is the most common one because you're only given you're given less information in the question, and not normally given the first, last, and the n in a question. So you're more likely to see the second formula pop up a bit more. But let's go through an example. Find the sum of the following series. Right, let's use both formulas. So we've got, in an AP of 11 terms, an arithmetic progression of 11 terms, A is equal to 1 and L equal to 6. So therefore, S of 11 is equal to half of 11 multiplied by 1 plus 6. So basically, it's 11 over 2 multiplied by 7, which gives you 38.5. And there we have it. That's the sum of that series. Now we have another sum. Find another sum question. Now let's say we have 10 terms, but we're not given the first and last term in this geometric progression. So we need to find the sum of the first 10 terms of an arithmetic progression with first term 6 and comma difference minus 2. Now this is just simply plug the numbers into the formula. You have a half of 10 multiplied by 2 times 6 plus n minus 1, 9 times minus 2. to have 5 multiplied by 12 minus 18. 5 multiplied by minus 6, which is equal to minus 30. The sum of the first 10 terms is equal to minus 30, and sometimes the minus can throw you off, but also you know that if you're given the first term and your sum of your term, the sum of your series is more than the first term, yet you have a negative difference, then you know there's something wrong. So it's easy to spot a mistake. And stay tuned for more. I'll post some more exam style questions, mainly from Solomon papers, and I'll also try to post geometric progressions too. Stay tuned.